Okay. All right, so I'm going to show you 3 methods of solving systems. Okay, first one is going to be by graphing. Okay, and I'm going to show you how to do it on the calculator. So method 1, by graphing. Okay, and we will do it on the calculator. Okay, so grab your calculator. Here's my example 1. You guys have silent mode on those phones? Alright, so if I'm going to do this by graphing, I'm going to start typing these into the calculator. So hopefully at this point you know that a calculator can only accept y equals. Okay, so the first step is simply setting each of the equations equal to y. Okay, so on the top equation, would we all agree that y is equal to 4x plus 18 minus 18? Okay, and on the bottom equation, let's see, you would do negative 4y equals negative 3x plus 20 divided by negative 4. So y equals to 3/4 x minus 5. Everybody okay there? Okay. So I'm going to start by graphing both of those in the same window. So we're going to hit y equals, we're going to clear out what was there before. It's a regular because it was a negative over a negative. Because you subtracted and then divided by negative 4. Negative over a negative.
Oh, okay, I'm following.
Oops. Okay, so x minus 18. And then I'm going to use my fancy little fraction button. Alpha y equals and do 3/4 x minus 5. Everybody okay with that? Okay. I would prefer that you at this point hit a zoom 6 instead of just graph, because sometimes the person who used the calculator before you changed the window. Okay, so looking at these 2 equations, what am I looking for? The intersection, right? I'm looking for where the 2 functions intersect. The calculator can only find solutions that are in the window that you see. Okay, luckily we see this one, so what you're going to do is you're going to hit second trace. Any guesses on what one you're going to choose? Intersect, number 5. And since I only have 2 functions in here right now, it asked me for the first curve, which is going to be the first y equals that I typed in, then the second curve, which is the second one. I hit enter. And then a guess. Now a guess becomes important if you have 2 functions that cross more than once, like maybe you have a straight line with a parabola. Okay, so you would have to say, I want you to find this intersection and put your cursor really close to that one. But if they only intersect one time, you can just hit enter and it will know which intersection you're looking for. So I'm going to hit enter. Okay, so I got an intersection of 4, negative 2. And so I'm going to write as my answer 4, negative 2. Okay, I will write it as an ordered pair. I'm finding a point where they intersect. What do you think? Should I do one more example of that? One more? Okay, let's do one more. Seeing some shakes of yeah, please. Okay, so let's say this time we have 3x minus 2y equals negative 6. The other one is x plus y equals negative 2. Okay, so before I type this in, I got to do a little bit of algebra on the top equation. I would subtract the 3x. And then what? Divided by negative 2. And so this equation is 3 halves x plus 3. Okay, on the second equation I have x plus y. How would I solve for y there? Subtract the x, right? Okay, so those are the 2 equations I'm working with. So on my calculator, I go to the y equals, and I type both those in. So I'm going to clear my previous ones. So I've got alpha window to get my little fraction, 3 halves x plus 3. Okay, second one, negative x minus 2. Okay, so then I'm going to hit graph. I know I'm in my standard 10 by 10 window because that's what I did last time. Okay, so I see the intersection in my window. I'm good to go. What do I push?
Second trace.
Second trace.
5.
5.
Enter.
Enter. Enter. And everybody get negative 2, 0? All aboard? Negative 2, 0. How do I do? Good there? Move on to method number 2. All right, so method number 2, anybody remember a second method? How? What's the method?
What about the ones where you add it together? That?
Elimination?
Yeah.
Yes. That's going to be my third one if that's okay with you. I'm going to do substitution. There you go. Doesn't matter which one we do first, but substitution. Example 1 of substitution. Let's do 2x plus 3y is equal to 9, and 5x minus y equals 4. Okay, so who remembers how you do substitution?
Solve for one variable, plug it into the other equation.
Very good. Okay, so we're going to solve for one of the variables. Of those two equations, which one is the easiest to solve for? The bottom one and set it equal to y, right? I would agree with that. So if I solve for y in this one, I could just add the y. So it'd be positive 5x minus 4, right? Because if you subtract 5x, then you have negative y. So you have to divide by negative. Right? Okay, so then I'm going to actually do substitution, and I'm going to substitute this y into the y of the other equation. Okay, so my work says 2x plus 3 replaced with 5x minus 4, 9. Okay, so at this point I have a linear equation. What are my steps? Distribute, good. So I have 2x plus 15x minus 12. Can I go ahead and add my like terms on the left-hand side and also add 12 in one step? Everybody okay with that? So I would have 2x plus 15x to make 17x's. And then if I add 12 to 9, what's 9 plus 12? 21. Ew. Okay, so I got an x value of 21/17. Everybody agree with that? Anybody get something different? It just looks ugly. I feel like I made a mistake, but I don't see it.
That is pretty ugly.
It's ugly, right? All right, well, am I done?
Probably not.
Yeah.
So you have to solve for the other one.
Right, I need a y, right? When I graphed it, I had an x and a y value. I still need to have an ordered pair as a solution. Okay, so how do I find the y? Okay, good. So since I have an equation that's already set equal to y, I'm just going to plug it in right here and do 21/17 minus 4. I'm going to use my fancy calculator. So 5 times, whoops.
2.176.
Oh my gosh, you're so much faster than me.
Well, I just put it in parentheses and divided it instead of having a couple of it.
Yeah, it makes it better. I
But
mean,
it looks-
nicer
it
that
looks way
but
better.
it does
But it's the same thing.
Well, we'll see.
That's what I got to.
Mine
37.
didn't turn into a fraction.
Uh-oh.
Mine gave me a number.
Oh, then hit math fraction. So just hit math fraction. 37/17.
Yeah.
So when I write my answer, I want to make sure that I write it as an ordered pair. So I would write it as 21/17 and 37/17. Nice, that's a gnarly one. Should I do one more of those, or do you guys feel like you got it? Anybody want one more? Going once, going twice. Sold! Alright, you guys got this one. Last method, everybody's favorite.
That's the path.
No, that wasn't actually. Everybody usually likes elimination the best. It's pretty simple. So question 1, let's say we have 7x plus y equals 9 and 5x minus y equals 15. Okay, so elimination method is the one where we're going to add or subtract straight down and eliminate one of the variables. Okay, so you have to make a choice right away and say, okay, am I going to eliminate the x's or am I going to eliminate the y's? So it is definitely easier to eliminate the y's. You could eliminate the x's if you wanted to, but let's do the y's. And my second decision is, am I going to add or to subtract in order to eliminate those? I'm going to add. Okay, so I'm going to draw my line, and I'm going to add straight down. So what's 7x plus 5x? 12x's. My y's are eliminated, and now I have 9 plus 15. 24. So I can solve this equation. Divide by 12, and x is equal to 2. Okay, so again, I'm not finished. I need a y value. How do I find my y value? Plug it in. And does it matter which equation I use? No, I can use the top equation. I can use the bottom equation. They both look pretty much the same. I'm going to just use the top one. So if I plug that in, I get 14 plus y is equal to 9. So 9 minus 14 is -5. So I get an ordered pair of 2, -5. Okay, so please make sure, you guys, that you're writing your answers as ordered pairs. Don't say x equals this, y equals that. Okay, write your answer as an ordered pair. Should I do one more example of elimination where they don't eliminate right away? Just for practice sakes. Let's do let's do a hard one. I'll do the hardest one you might see. 3x plus 10y, just so you have a good example. Rather see it now than later when I'm not around, right? I might. Yeah, okay, so for this one, first decision, am I going to eliminate the x's or eliminate the y's?
I said X.
Okay, I would agree with x. You could absolutely eliminate the y's, but you have less high numbers to multiply by with the x. So if I was going to eliminate the x's, I need to have the same value in front. So I have a 3 and a 2. What's the least common multiple of 3 and 2? 6. So I need to make both of those turn into 6's. So what am I going to multiply the 3 by? 2. And what am I going to multiply the 2 by? 3. Okay, now here is where people make mistakes. When you multiply these equations by whatever number, a lot of people forget to multiply the constant by that number too. Okay, so remember you have to multiply everything on the top equation by 2. Okay, so you're going to have negative 6x plus 20y equals 10, every single term. Okay, on the second equation, same thing, I'm multiplying by 3, 6x plus 21y's. Ooh, what's 24 times 3? What? 72, yeah. I know you said 7. 7. Close. Okay, so now are we going to add or subtract? You're adding straight down. Okay, so adding eliminates our x's. If I add my y's, I have 20 plus 21. That's a total of 41. I'm not sure, 42. 1 y's. And then 10 plus 72 is 82. So 82 divided by 41 is 2. So I got a y value of 2. How do I find the x? Plug it in. So for this one, I could choose any of the 4 equations. I could pick the given ones, or I can even choose one of the ones where I multiplied. It doesn't matter. They're going to give me the same value. I'm just going to use the top one. 10 times 2 equals 5, so negative 3x plus 20 is equal to 5, so negative 3x. Let's see, that would be negative 15. Anybody else get 5? Okay, so 5, 2 is the solution. Awesome?
Definitely.
That's so easy. Piece of cake. All right, so your assignment is on page P22. Don't forget the P. You got 2 through 46 evens. And there's a couple absolute value questions in there, and I didn't show you how to do, or not absolute value, there's a few inequality questions. I'm going to let you guys play with those on your own and see what happens when you come back on Monday. See if you can play a little bit.